Hello, pirates. Today we will be looking at the difference between heat and temperature. Oftentimes, you will hear these two terms used interchangeably, but scientifically, they are two very different quantities. First, let's take a look at temperature. Temperature is a measurement we are all familiar with, be it in terms of weather, like a balmy 90-degree summer day, or a sub-zero winter night, or in terms of objects, like a cold glass of lemonade or a hot cup of coffee. Despite seeing this measurement in many aspects of life, many people only think of temperature as a way to measure degrees of hot or cold, when in actuality it measures an object's average kinetic energy. Kinetic energy refers to the energy an object has because of its motion. So the faster an object is moving, in this case atoms and molecules, the higher the average kinetic energy of the sample being measured, meaning a higher temperature. Let's take a look at an example. The molecules on the left are moving very slowly, which means they transfer very little energy to the alcohol or the mercury in the thermometer, and as a result, we see a lower reading on this thermometer. But if we take a look at the picture on the right, the molecules are moving very quickly. These fast-moving molecules transfer a lot of energy to the alcohol or mercury in the thermometer, which causes the temperature readout on this thermometer to be much higher. So if temperature is only the measurement of kinetic energy, or how fast particles are moving, then what does heat measure? Well, heat is the measure of total energy. Let's take a look at the three components that we need to measure to determine total energy or heat. We have the amount, or the object's mass, the type of substance the object is composed of, which is scientifically known as the substance heat capacity, and the object's change in temperature. It's important to note that heat includes temperature in it, but is not limited to it. Heat and temperature are not the same thing. Now let's take a brief look at each component. First, we have the amount of an object or its mass. Let's pretend we have a glass of water right next to Lake Michigan. In late October or early November, the temperature of Lake Michigan is about 60 degrees Fahrenheit or 16 degrees Celsius, but the average air temperature is about 40 degrees Fahrenheit or 5 degrees Celsius. If both the glass of water and the lake are at 16 degrees Celsius, which will drop down to 5 degrees quickest? Since the glass of water has maybe a half a liter worth of water versus Lake Michigan that has nearly 5 trillion kiloliters worth of water, we can safely say that the water in Lake Michigan has a greater mass. And even though both have the same temperature, the lake has more heat because it is more massive. The glass of water will cool off in a matter of hours, while the lake will take months to cool down to 5 degrees Celsius. This is one of the reasons Chicago experiences the lake effect. Like other large bodies of water, Lake Michigan slowly gives off its heat to the surrounding air, causing the air near the lake to be a bit warmer during the fall and winter months than that of the air further inland. This is why when you watch a weather report in the fall or winter, the meteorologists constantly say that it is a few degrees warmer near the lake than it is in other parts of the city or surrounding suburbs. The opposite is true in the spring and summer. Since the lake spent all winter cooling down, it will now spend the spring and summer months warming back up. The cold lake will absorb heat in the spring and summer months, leaving the air near the lake a bit cooler than other parts of the city or surrounding suburbs. The same is true for any land that is near a large body of water. However, Lake Michigan's enormous size is only one factor that causes the lake effect. The other factor happens to be our second component of heat, which is the type of substance or the heat capacity. The amount of heat something can hold is not only determined by how much of the object you have, but it also depends on the object's ability to hold on to heat. We call this property a substance's specific heat capacity. Water has a relatively high heat capacity, meaning it can take a long time to heat a substance up. The opposite is also true, as water takes a long time to cool down. Sand, on the other hand, has a relatively low heat capacity, meaning that it heats up very quickly, but cools down very quickly as well. If you've ever been to the beach in the summer, you know that during the day it can be painful to walk on the sand as it gets so hot very quickly. But in the evening, as the sun begins to set, the sand cools off and is much less painful to walk on. This phenomenon also explains why deserts can get so hot during the daytime, but can actually get cold in the evening. The third and final factor is one we've already talked about: temperature. When we measure heat, we are actually measuring the transfer of thermal energy, and according to the second law of thermodynamics, heat will always flow spontaneously from areas of high temperature to areas of low temperature. This being the case, in order to measure heat, we can't just measure one temperature, but rather we have to measure a change in temperature. This idea will be discussed further in subsequent videos. That's all for today. I hope this helped clarify the difference between temperature and heat. Have a great day, and go Pirates.